very important topic to all of us. We must learn important things about this forest fire. So it's a great opportunity. I welcome Dr. Manoj Kumar, scientist and in charge GIS Center and GIS discipline for Research Institute, Dehradun. So I request our organizing secretary, Dr. Saroj Kumar Patnaik, to formally welcome our.
Good morning. Good morning, Manoj. So,
good morning.
I already met Dr. Raja has briefed about topic and all. So we are fortunate to get Dr. Manoj Kumar as our the speaker because he's
Good morning. Am I audible? Hello, good morning. Am I audible? Can anyone confirm, please, whether my voices are reaching? Hello?
Speak now.
some we could just Manoj, can I hear me? Can you hear me? I'm meeting
Yes,
and
yes.
just,
Your
going
voice
through
is
the
reaching, but it is
paragraph
breaking.
today's speaker. Some notice is there, but I think it's okay in some sense. So, Dr. Manu Kumar.
Hello? I'm not sure whether my voice is reaching
Okay.
or not. Can anyone please confirm?
Your voice in here.
Okay.
Here also and so now he Kumar is investigate projects from DBT. So running institute.
So, okay. I have allowed unmuted everyone. If I have given this privilege to ask in between, so from my side, I have allowed to unmute every participants. So I will request that you please unmute yourself and please confirm whether my voice is reaching you clearly or not, because we are in online mode and we should be confirming the two-way communication. Otherwise, what can happen, I will be simply speaking and maybe you are ideally sitting without any message being transmitted from my side. So I request participants to unmute themselves so that in between, if I confirm whether my voice is reaching, you can confirm from your side. So can anyone please confirm whether my voice is reaching? Let us make it a two-way. Otherwise, it will be boring. I want to be an interactive session. Hello? Okay. Okay. So maybe for 5 minutes we can wait for others to join. I received just a call from your center. Dr. Patnaik is putting a lot of hard efforts for successfully starting and now this workshop. Huh. Okay. Thank you. So let us start the session for today. So first of all, I thank the organizers for taking all the pain in successfully organizing this meet. Uh, Although it is an online meet, there is a lot of hindrances as we are facing just now also, but confirming the two-way communication. But anyway, let us try to make it a successful one. So once again, I thank the organizer, especially Dr. Patnaik, who is taking a lot, making sure that everything goes smoothly. In between, he is often calling me as well as maybe he is calling to the participants also. I can see, although it's the last day, and usually in all this seminar, all the attendance mostly is on the first day, and by the last day, mostly attendance is like this only. So in the initial day, I could see nearly 70 participants, but today we have only, I think, 10 plus only. Few are the host, co-host only. So I believe that those who have come here, they are really interested. They are the real listener. And with this view, I am going to present my things. And that's why I have made it a two-way communication. From my side, I have given permission to everyone. Everyone can unmute themselves. If you have to ask anything, I will request you please don't hesitate. In between, you can stop me.
I'm sorry, actually, I have muted everyone. Sir, I have muted everyone, so they cannot unmute themselves. So now you have to unmute yourself and start the session. So can you hear me? You have to unmute and speak now.
No, my voice was not reaching. I am already speaking. Out there. Hello.
Yeah, you can continue, sir. Now.
No, my voice is reaching or not?
Yeah, we have. Yes, perfect.
Okay. Okay, so again, whether I was able to convey, I am speaking since last 5 minutes. And I have allowed everyone as a host, I have allowed everyone, they can unmute themselves so that in between, if my voice stops reaching you, you can directly interrupt me.
We will handle that one. Yeah.
Okay. Otherwise, it may happen that it will be one-way communication. I will believe that everyone is able to listen me. Some problem is happening in this Zoom. The options are vanishing. Okay, I am going to share my screen. Unwanted stuffs are coming. It is Zoom free version. So I'm trying to share my screen. Can anyone confirm my screen is visible?
Yeah, it's visible.
My screen is visible
Yeah,
now?
you can press that slide view. Yeah.
Okay. So in this 2-hour session, we are going to discuss and talk about this broader aspects of forest fire, its monitoring and management, and detection. There is problem, some bugs is there in this. I have shared my screen. Can again please confirm if my screen is visible, my voice is clear?
Yeah, yeah, it's visible. Yeah, it's visible.
Okay, okay. So forest fire monitoring, change detection, and some vulnerability assessment using some vegetation model. 3 aspects we are be covering in this 2-hour session. So I am Manoj Kumar. I work at Forest Research Institute. There is one center under IT and GIS disciplines. So we look mainly at 2 aspects, IT and GIS. Its application largely in the forestry sector and other allied sectors like environment or climate change or little bit of other similar kind of disciplines. Largely we focus on the forest, and largely we apply this IT tools and GIS tools, remote sensing GIS tools. So here I have got a privilege, a chance to unnecessarily one software is opening. I don't know why today only it is happening. Sorry for this kind of interferences. Please wait for just 1 minute. I'm trying to remove the. So hoping that everyone is quite aware about these issues of fire, especially in this, if you are in Northeast region, if you see the entire scenario of our country, this forest fire is most prevalent in this Northeast region particularly. And I live here in Uttarakhand also, this forest fire is a big issue. And recently, our Ministry of Environment, Forest and Climate Change, they have given us this assignment to establish Center of Excellence for controlling this forest fire. So we will be coming very soon with this center, who will be looking after the entire nation to work on the various aspects of fire prevention, especially with respect to the forest. And we know fire, its origin is from a Greek word, which is pyra, meaning flame. And in forest, usually we have surface fire that is on the above the ground, which is visible. You can see when there is dry material available on the surface, and by chance, if it comes in the contact of any source of any fire, this forest fire starts in the forest. Then we have this subsurface or the ground which is just below the surface. Then we have the underground one which is not visible one. Three, only the surface and the crown one you can visualize. Otherwise we have this underground. Sometimes we have underground fires also. When you will see at the top of the surface of your forest, it will look nice, but beneath it, there is a fire and it slowly spreads, and in due course it may take a shape of ground fire. So if you look at the broader aspects of this fire, especially in the forest, not only with respect to India, but for entire globe, it is mostly man-induced fire. There is very little bit of natural fire due to this uh, continuous rubbing of the dry twigs or the branches of the trees, or sometimes due to thunder and lightning. But mostly we see that across the nations, the fire in forest is mostly human induced, man-made. It is very much less. This natural forest fire are very less. So we as a human have to take a precaution in various ways. Maybe we'll have to look at the specific area about the causes which is generally prevailing to spread these fires. One minute. It is showing 11 participants in the waiting room. Admit all. Okay. We have for few more participants. Welcome all.
I'm admitting them, sir. You continue, please.
Okay, you are handling this issue. Okay, thank you for your kind support. You please handle these issues. You are also a host there. So, not always these forest fires are intentional, but sometimes it is intentional also. Like when villagers in some regions, they want to reach fodders, they intentionally burn the part of the forest so that there is cycling of the nutrients, and in due course they can have a good growth of grass. I don't know whether it is happening just from your side or my side. And sometimes intentionally they also burn these forests to destroy the evidence of illicit felling. If they extract all, as you know that from forest area it is prohibited to cut these trees, but sometimes villagers, if they do, they want to suppress these evidences and they do this kind of burning. So sometimes it is intentional and sometimes it is also the unintentional one. Suppose you are doing some activity in nearby agriculture land, and from there by chance in an unintentional, it may reach to the nearby forest area and we have this forest fire. Some unintentional burning is once any visitors or villagers or the community living near to the forest, if they are going into the forest area and they throw this butt of the cigarette or the bidis, that creates this burning of the forest, and there is forest fire. And the natural causes is very little, and it is mostly because of maybe sometime there is a lightning, maybe due to the rubbing of dry branches, or when there is such a large amount of heat that it reaches the burning point of the fuel available in the forest. Then also there is issue of this forest fire, that is natural one. In India, you see natural causes are not significant mostly, and I have written India, but mostly in all the nations, the scenario is almost the same. We have mostly this human-induced fire, natural for forest fire, very less. If we talk in with respect to the Uttarakhand, we have largely dominated forest by cheer pine, the Pinus roxburghii. Almost more than 16% of the area is having this cheer pine forest. And if we look the trends of forest fire in different forest types, we see large amount of forest fire in this cheer pine forest area. And in cheer pine, the forest department, sometimes local community, they use this extraction of resins from this pine forest, do the tapping, and for tapping they expose this trunk area, they cut the bark, thick bark, and when it is exposed, it becomes prone to the forest fire, and we have the forest fire. In pine area, we have a large amount of fuel available at the bottom in the form of dried needles, huge deposition, and that quickly, it is this fuel is available quickly for the burning, and quick spread of fire is happening in these areas. So in fire triangle, we have already seen three components are essential. One is the instinct of the fire itself. I don't know why it is happening. I take class daily on the same system for my master PhD students. Never it happened. It is Zoom related problem. We are using Zoom. Some unwanted message.
Hello?
It is writing at the bottom.
Dr. Manoj?
Yes.
Myself, Dr. Patnaik. Hello.
Yes. Your
Actually,
voice is
here
coming.
network is okay. Here also, we can see it is okay. I think maybe in our laptop something is there, or I don't know. From the last 2 days, some problem is there in your laptop, maybe. But you continue. We'll see.
Open, asking to open. Yeah, let me see.
Okay.
Yeah. Okay. Sir, actually, I'll give this take out all the privilege. Like everyone can unmute and speak. So I'll just change it. And meanwhile, you can. I think you can stop screen and start once again after opening the PPT. You just click on that PPT and share. Then it will be good. It will be really good. First open your PPT and then share screen.
Hello. Namaskar. जी मैं आपको कॉल करता हूँ कुछ देर में. Okay. Is this fine now? Voice is reaching. My screen is visible. Please confirm. Hello. Hello. Kindly confirm whether I am audible or not.
Hello?
Yes.
Hello?
Yes.
You are audible. Hello. Please continue.
Okay. Kindly ring me in between.
Hello.
If there is some problem, you
Please
can ring
continue.
me. On my mobile, please stop me, interrupt me if there is
Okay.
one-way
Continue.
communication.
No. Please continue. Please. Okay.
So I suppose that everyone is aware about this kind of situation, maybe through news channels, newspapers, or maybe sometime live. If we see the forest fire statistics of India across the assessment year from 2001 to 2016, we did some small analysis few years back. We can see up and downs across the year. Sometimes the forest fire is high, sometimes it is low. Maybe because of the various prevailing local situations that we will have to see, visualize. But the point is, large amount of these fire incidences you can see. There is significant damage done by this forest fire across the country in all these recent years especially. Maybe in the initial year there was less capability to this capture this information, so we can see that maybe there is less reporting, but now we have gradually improved these capabilities to sense and detect this forest fire, and we are in more better way in a more better position to control it also. So both thing is happening. We have improved our capability for controlling early warning system we have developed, and we are still in developing more precise early warning system for early precautions, early preventing measures to suppress these fires. And at the same time, by the evolution of sensors in the space, we have improved this capability to sense these forest fires. If we see this classification of forest based upon density, middle density forest, especially the open and moderate dense forest, are more susceptible, more prone to these fires compared to this scrub or very dense forest. If we see different forest types of our country, in your northeast region, you see this highlighted, the third one, tropical semi-evergreen forest. If you visualize the forest fire sensed by our sensors placed in the space, there also clearly will find, you will witness that you have very high density of this forest points in these areas. So lastly, this middle and this areas, tropical dry deciduous forests highlighted with this color, we can see it is the topmost prone area in India where the forest fire is happening, followed by this tropical moist deciduous forest, which is also prevalent in the northeast region. It is really very difficult. Why it is happening so? Some 1, 2, 3, 4, 5. I'm not doing anything. Already system is doing it by it. Say the number next to item you want to. If it is from the organizer side, I will request to unlink that system because of which it is happening. I can present it through here. I can share the phrase link, WebEx links. That is a professionally.
Yeah. No,
This way,
actually,
it will be very difficult. We
yeah,
have
I
to bear
think,
2
sir,
hours.
yeah, actually, I will disable all the page of unmuting. It has automatic. So I'll unmute all of us and then let me. Otherwise, you can close your windows. I think there was a problem in your system. You close windows and let's for PPT first. and then share the screen. And you can speak. So now you can mute. You must unmute.
Whether my voice is reaching, I'm not sure whether my screen is visible.
Yes, reaching. Yeah,
Okay.
reaching. Yeah, reaching.
So if we see these different forest types of our country, largely these 16 groups given by Champion and Set, still we are following that classification. The highest dominance of this forest fire we see in this tropical dry deciduous forest. And then there is dominancy of this forest in this northeast region also, where largely we have this tropical moist deciduous forest and tropical semi-evergreen forest. In these three kind of forests, mostly if we analyze the last 10 years forest fire data, we could see the high forest point density in these forests. So if we see the further the statistics of different states, sensed by this MODIS sensor, which detects this forest fire, you can see these are the top 10 states of India where the forest fire is more prevalent. Assessment period 2001 and 2000, at the end of 2016 only we did this assessment. Recent assessment is not available, although we can do it. We can see out of this 10, 5 of the states are in your northeast region only. Mizoram, Manipur, Assam, Meghalaya and Nagaland. So this forest fire is a major issue for even for this northeast region, forest of northeast region. Maybe because they have adopted this safety cultivation kind of practice, that can be one of the major contributor. And the other contributor needs to be assessed locally. But definitely this is one of the big issue for all these states, especially the 5 states of this. Now, sorry for this interruption. I express my sincere apology. I don't know why it is happening, but it is disturbing continuously. Whether I am also only the person who is facing this problem, hopefully all the session will smoothly.
Sir, I think this is the first time we are facing that experience. I think there is a problem in your laptop. It looks like that. And there was a virus is automatically opening the window. There was, I think if you close our applications, even if you take a shutdown and stay to one second, it will be call the application and then start it again fresh. It will be good.
Okay, just wait for 1-2 minutes. I am trying to close all this.
Yeah, you can exit and then you can come in. First, you can exit, sir.
Okay, let me close all the things. I have closed. Let us see.
You can shut down and you can exit the.
Okay, let us see if it goes fine.
Yeah, now looks okay. Let us see that.
If we see the recent year statistics since 1st November 2019, the status of various states related to the number of occurrences detected by this MODIS and SNPP sensor, which gives this VIRS, that uses this VIRS sensor. We see this, these are the top 5 states in our country: Maharashtra, Telangana, Odisha, Madhya Pradesh, and Andhra Pradesh. Maybe if we change this assessment year, you will find very different statistics. Again, I think the problem is persisting, but anyway, please bear with me. Just this thing I wanted to highlight. If you see the fire point density created from this MODIS detected fire point for this assessment year 2001 to 2016, if you continuously scroll over all these assessment year, you will find that this region, your region where you are presently located, you are in the Arunachal Pradesh, but the northeast states, especially this lower side, and sometime in this region also, you will find the highest number of this fire point density. It has been created from the fire points, the density for India level, and some fire point you see in this region also, this across these lower sides of Himachal, Uttarakhand, and this Jammu Kashmir, lower bottom side, and in this middle region, in this Madhya Pradesh, and here in this Andhra region. Now see in 2002, you see maybe in this region this intensity is changing, but compared to the previous year, more or less in northeast region, you see the more or less the same kind of situation. Although this forest fire is not seen in the 2002, but if we see scroll across the years assessment, you see maybe here we are getting less density, but always in northeast region we are having high fire point density. So see this in 2004. My God, why? In 2005, in 6, in all those years, you can see that in northeast region, continuously we have the highest fire point density. Maybe in other regions it is less, but continuously in all the years, we have this problem in this northeast, especially these northeast states. In 2010, 2011, 12, this is 13, this is 14, 15, 16. We can create similar maps for this coming years also after onward this 2016 period. All these statistics now it is available on this. We will see on the website of this Forest Survey of India. There the option is there. You can select the states and all different statistics we can see related to the forest fire. It will be shown in the coming slides. If we see the fire detection, okay, please take a 1-2 minute break for changing the system. I am changing the system. I think it is happening from my side. It will be good. I'm changing the system. You can give me for 5 minutes break. All of a sudden, all these things are opening at its own. I'm not doing anything.
Uh,
We can stop for just 5 minutes. I am changing the system.
Sir, you can use another system.
Yes, yes.
You can use another system, or you can shut down and you can.
No, I am using another system. I'm changing it. Some virus is there.
Yeah, you can exit now and you can join in. Yeah. Hello, sir. Can you hear us? Hello, sir. You can exit your share screen and you can join into the Zoom. Then it will be connected. Sir, need you co-host to hear? Yeah, I'm co-host. You can start. Sir, I'm you co-host. So you can unmute yourself and you can. PowerPoint. You have to click on the PowerPoints. अनम्यूट कर दो. Sir, it's not audible. Hello, sir. Can you speak? Sir, can you speak now? थोड़ा उधर ही आना. थोड़ा फोटो फोटो. मेरा इंटरनेशनल विजिट है क्या? कितना कंट्री गया है? 3 साल अभी मांग रहा है. थोड़ा वर्ड में टाइप किया था. थोड़ा देखो. यहाँ में है क्या? एक वर्ड फाइल में टाइप किया था. ट्रेनिंग रिपोर्ट ऑन इंटरनेशनल कॉन्फ्रेंस राजा इंटरनेशनल सिम्पोजियम. ये नहीं है ना. एक स्लिप बनाया था वो अभी 3 साल अरे क्या प्रॉब्लम था?
Yes, switches to another one.
Okay. Is it audible now? You can unmute and you can speak.
To him. You also make
So now speak now. Whether audible or not. Can you speak?
hello.
So can you speak now?
Should I call?
All the participants, I request everyone be patient and wait. We have some technical issues from the speaker side. We are trying to solve it. Wait patiently.
Hello, Dr. Manoj. Am I audible to you?
Yeah, I can't wish to
Hello, hello.
Is it okay to ask? No, yeah, you just call again. Let me fix this.
Hello. Dr. Manoj, am I audible to you? Hello. They have not started yet. They are just discussing what to do in the conference room. Don't. हाँ राजा थोड़ा इसको हेलो हाँ
उसको ज्वाइन
हाँ
किया ज्वाइन किया तो
जान कैसे हाँ but no audio is not audible.
Yes, wait.
Hello.
Wait. Yeah, sir, I'll make you co-host now. Just a minute.
एक बार शुरू होने से राजा चलता रहेगा ना हमारे मैडम लोग तो कर लेगा वो क्या गड़बड़ हो गया
Just I'll make you this system.
ना
Can you unmute now?
Yes. Now it has been
Yeah.
unmuted.
Now it has come.
Hopefully my voice is reaching.
Yeah, now it's audible.
Okay.
Yeah, yes, perfectly. And
I
now
think
you can share only the PowerPoint actually.
yes,
Only
yes.
open the PowerPoint, and when you press this share screen, only open that one. It will be good. Sir, open the
Okay,
PowerPoint
okay,
first.
let me share my screen. Okay. I
yes
think it is now my screen is visible now.
Yeah, now it's okay. Now it's okay.
okay thank you
Yeah,
please,
perfect.
please go ahead
Actually, sorry for such kind of questions we are facing. Usually at this institute level, we are the people to supposed to facilitate everyone in this institute. So we also struggle for such kind of problem. So sorry for all the inconvenience. So we were here discussing this. Again, I just wanted to confirm whether my voice is reaching. The screen is visible clearly.
It's visible clearly without any disturbance. Now it's perfectly all right. You can continue.
Okay, thank you. Thank you very much for the confirmation. So we were discussing all those with interruptions. These forest fires are also an interruption in the forest ecosystem. We see the trends. If we see the season-wise trend during the winter and during the summer, obviously this hot season are the more prone season for this forest fire. This forest spots detected by this modis you can visualize in these two screen. Left side is the winter season and the right one the summer season. More dots in during the summer season. So definitely this season is one of the prevalent factors. So that's why after this, especially in this after February month, we in particularly for Uttarakhand region, we become forest department becomes very much on alert mode for the prevention of and the suppressing of this forest fires. So season definitely plays a role when there is hot climate, when the temperature is enough high to reach to the flame point so that the fuel can ignite itself, there is more risk to this forest in this summer season. So these red spots are the forest spots. If we see, we analyze this 18 years data retrieved for this from this MODIS, especially for the three states of Western Himalayas, Jammu, Kashmir, Himachal Pradesh and Uttarakhand. We can see, and this was divided into the grids at 5-minute interval, roughly 10 kilometer, say it 9 kilometer. In each of the grids, these red dots have been highlighted in the left panel. We can see almost in 18 years, in one grids, almost 154 times fire points have been detected in all these years. So this is an issue that needs to be addressed, and it all these intensity varies across the states. We can see, although there is less forest in Jammu and Kashmir, so less forest fire detection, and we in Uttarakhand we have large amount of these forest areas. So and we are at the lower latitude also and at the lower elevation. Here the problem in especially in Western Himalayan region, the problem of fire is more prevalent in the state of Uttarakhand. So such analysis we can do for entire states. Nowadays, Forest Survey of India website, they are also giving such kind of statistics. You just need to select the states or entire nation, all the figures, all the statistics they are providing. Nowadays, after the establishment of Center of Excellence in Forest Fire, we will soon be starting such kind of dissemination system, which maybe I will be updating you through the emails. In coming slide, we will see what are the various statistics available through Forest Survey of India. They are also doing extensive work on this forest fire alert system and dissemination of information related to the control and prevention of this forest fire. This is the forest fire monitoring site by FSI. Everyone might have heard the name of this FSI. It is a Forest Survey of India. This institute in Dehradun, located in Dehradun, and there at their website you can see especially this tag, this forest fire. If you click on forest fire, various statistics, various themes, various other information related to forest fire, you will be able to see various activities, what they are doing, focus area, and all these things. You see this dissemination, alert dissemination system. So since March 2010, roughly last 10 years, they are also sending this SMS and email based alerts. You just need to, any individual can register their mobile number or email number for receiving the alert for their area of interest. You will have to select, you will have to make your profile, and you will have to give this option. You want to receive this SMS alert or email alert for whatsoever reason. According to that, the fire alert system, which is based upon the remote sensing sensors, MODIS and VIRS, they will be sending you alerts on your mobile, and also through, there is option to receive this alert through email also. So that especially this forest department, they take the help of this alert system. All the staffs repeated in their respective beat or the range, they receive this alert for their administrative area, administrative boundary in advance. It is almost near real time. We cannot say just the real time it is, but it is almost near real time message they receive, so that they can deploy all the resources for the fighting of this forest fire in their respective administrative control region. So this is the interface. If you click this interface, let me very fastly show you. I have already wasted enough time in this handling this computer related problem. This is the domain name. If we quickly see what kind of information it is available here. Sometimes there is server is down. It is not very much in the public domain. Still they are in the development stage, but these are the various kind of information you can access from their server. They, like forest fire alert system, they have named it. It is web-based system where through server they are disseminating all the information connected through connected computer through internet to their server. You can fetch information, various information. For becoming a new user, you will have to sign, or if you are already a registered user, you can register here itself for receiving all the alerts. They usually use this VIRS SNPP based sensors and this MODIS. Particularly in a day 4 times they are receiving this information, because if you want to prevent forest fire on real time basis, then you need a almost near time forest alerts, so that when once there is any fire in the forest, immediately you are receiving message that at that particular area. It gives you lat long also. There is a forest fire has occurred, and you can send your units, your administrative units and all control measures you can deploy in those particular area for the dashing of these forest fires. So let me very fastly again confirm whether it has opened. Yes, it has opened. Now you can see various kind of statistics you will be able to see, you will be able to retrieve. You just need to select the kind of stats you want. State by, it is giving the registration state wise for receiving the forest alert system. Mostly it is in Himachal Pradesh. They are working. They are actively using this forest alert system. So here the number of user is very high. Next, this Maharashtra and this Telangana, it is just showing the number of users registered for receiving this alert system in various states of our India. From here I use one information in my slide also. It is top 5 states with highest number of fire alerts. Here you will find 3 dots. If you click it here, you have this option to save as JPEG and this PNG format. You can save all these information from here. All those statistics you find here, from date, from which date to, you have this privilege. If you want to search another information, select the source. Basically they are using 2 sensors, SNPP and MODIS. So whether for all states you want or for any specific states, you can select from here a specific circle. If you select this, then they will give you the option of circle. In the states where there is no circle, you will not find that. if I select Uttarakhand, I can see all those circuits wise information. You can select the division, range, and accordingly you can have all this fire related information. So it is a very useful resource. I have already shared this link this in my slide. I will share the slide also after this presentation. I will email to Dr. Patnaik. He can share with the participants. I will suggest that you just go to the rich information available here. You can explore the various kind of information you can retrieve for this forest fire related information. Earlier we were having this NASA based platform where MODIS and VIRS sensors related informations. Following the similar pattern, the FSI has tried to develop its own platform. They are similar to these firms. Fire information for resource management, one system developed by this NASA group. They so various kind of information related to global forest, not only for their country, but for entire globe. They provide multiple kind of information that again we will be seeing in one of the slide. The FSI also has developed such kind of system where you will have the privilege to select which kind of information you want for which area you want. All those options you can select and unselect, and accordingly you can fetch multiple information related to forest fire monitoring. All the information retrieved from the sensors in present time, as well as all the archived previous year information also, it is available here. All the archive information you can fetch from this website. Now this server is down, this time it is not opening. I will give you the link, you can try this multiple information. So what basic approach in remote sensing they are using? They are actually using the thermal sensors, that is detecting the fire points for a specific cutoff point. They detect high level of temperature in a given pixel of these two sensors. One is MODIS at a resolution of 1 kilometer and VIRS at the resolution of 375 meter. So VIRS is having higher resolution compared to the MODIS, and they qualify the pixels with highest temperature at a greater than certain threshold. They do this customization at their end. When in a pixel, this thermal sensor detect temperature above a certain threshold, they qualify it as a fire pixel, supposing that the temperature rise is because of this forest fire. So sometimes there is false detection also. They define this with their confidence limit, with what confidence they are declaring this, that these pixels are the forest pixels, these forest fire pixels. They qualify it as a forest points. They receive these sensors in the satellites. Through satellites they are receiving these signals of this forested landscape, and they are receiving this signal here. They are processing, after this retrieval they are processing it to qualify as a forest or this fire or non-fire points. At Forest Survey of India office, some into some lab, they are retrieving all this information through NRSC, National Remote Sensing Center at Hyderabad, and from there they are fetching all these information, they are processing it, and then through this alert system they have developed this system from where they are sending the information to the registered user for fire alarm, fire alert system through email and SMS. So all the state forest department, they have instructed their uh, especially those staffs engaged in prevention of the forest fire to have compulsorily registered their number for receiving this forest alert, so that they can take a timely action for the suppression of forest fire in their respective jurisdictional administrative area. So this is all steps. They use this remote sensing based signals for detection of the forest fire, and the deployment of resources and the staffs in the field for the prevention of this. This is the forms by NASA, which I was saying. If you click it, it will, this server hopefully will not be sleeping like our FSI server. You will get all these information here also. And following, inspired by this only, our Forest Survey of India, they have started our own this observation platform. If here you can see the various tags, active fire data, fire alerts. If you see active fire data, if you click it, you can download this. It will come into zip point safe file. You will be able to download for this MODIS. You will have the privilege to select whether you want for MODIS, VIRS. Accordingly, you can receive this information. It is like this 24 hours, 7 days. All these sensors information, you can download it from here. And if you want to visualize various statistics on map, visual for your visual interpretation, you have this kind of interface. For if you select today, it will give you the status of today. You can see it is neat and clean right now. Our fire season has not started. You have this privilege to go for other options. If you click the advance, in advance you have this privilege to select 1 day, 2 weeks. The moment I select 2 weeks, maybe more fire points you will be able to visualize. If you select 2 weeks, some more fire points you will be getting. And they are the various sensors. 4 times in a day they are detecting it through these 4 sensors, and all 4 passing at 4 different times. So accordingly, if you want information sensed by a particular sensor, you can select it or you can unselect it. If you want to use this model Terra sensor, if you want both, so accordingly, rich information it is displaying. And all those multiple other options are available here. You can change it, and accordingly, like you can have there is some option to see the burnt area, and all those kind of statistics also is available in this website. So I will suggest this is also a very rich information is provided freely for the user. It is maintained by this NASA firm. They say it for fire information for resource management system firms. And in the similar pattern, this FSI is also developed. They use both these platforms are using the information retrieved from the same sensors, this MODIS and this VIRS. So this link is given, you can retrieve. It is VIRS is visible infrared imaging radiometric suit. This MODIS is, you must be aware, you must have heard, this MODIS is not only used for giving you these fire points, it is also giving you various forestry related parameters like productivity, evapotranspiration, all these parameters it is sensed through its various sensors. They are processing it into their lab and they are giving you the ready-made usable, ready to use products, leaf area index, all these information you can retrieve through this MODIS. And this VIRS is actually, it is installed on this SUMO National Polar Orbiting Partnership, this satellite. So SNPP based information using this VIRS sensor you are retrieving for this forest fire detection. So VIRS has 375 meter resolution, this MODIS Aqua, this MODIS Terra. Accordingly, you select and you will be able to retrieve information quickly within a click of mouse on your computer screen for entire globe. Accordingly, according to your interest area, you can select the region and there they will highlight you the selected information. So some of the initiatives that Government of India has taken for the control, one is this FSI group is already developing this alert system. Then in every divisions, this states at the state level, master control room has been established where they do all exercise work related to the advance retrieval of advanced information where there is high chances, high probability of forest fire, so that they can take advanced measures for the controlling and prevention of the forest fire. Then this National Disaster Relief Force and the state level disaster relief force, they are also being established and trained for controlling and prevention of this forest fire. So especially in Uttarakhand region, when there is forest fire, we see the state disaster relief people in action into the field for the control measures, because the intensity and the extent is so high. The few staffs engaged in forest department, they are not sufficient to control this. So now at the community level also, people, because all the forest department and NDRF, SDRF people are not into the forest area all the time. It is the community who is living near to the forest. They are the first source of information if there is any forest fire. And actually the causes is also mostly induced because of the community. They are either their this reckless behavior, this at their attitude, they all create this forest fire, or with their own intention uh, they are malified, sometimes malified intention to suppress illegal felling of the trees, or the forgetting high growth of the fodder from the forest area. They do this kind of intentional burning for preventing all these things. At the community level also, there is large focus in various states where this forest fire is a major issue, to make aware the community, convince the community about the ill effects of these fires, how it is going to alter the forest ecosystem, how negatively it can impact, how it less ecosystem services like water and all they are receiving from this forested land, that they are benefited. So this kind of activities this government of India has taken. So especially in this master control room, they do some fire danger rating, and accordingly they identify their high prone areas where the deployment and of resources and the people is at first priority, and then second priority, third priority. Accordingly they rate their area. And this exercise, it is nowadays it is automated, it is a computer based system. They are doing this. They require this few parameters like days without rains, and there's temperature and dew point temperature. And they use this equation developed by this Nesto in 1949 for rating of this their area. And accordingly they can prioritize the prevention and the control measures, allocation of the resources or the human manpower in their respective area for the control of this forest fires. Now these are the some of the pictures of this Uttarakhand states where these awareness programs to prevent forest fire, forest department are engaging the community. They are going into the communities for convincing them, for also for training them in case of forest fire, to whom they should be informing at first, what are the initial things they can do for the further spread of these fires, because the intensity sometimes it at such a large extent it takes a long time to control it. It is sometimes it is even the beyond of control of the local community and even the forest department. So through awareness program also they are spreading this. These are the resins stocks in the forest department depot. They are all susceptible to the fire, so they do the sprinkling of water to prevent further spread of the fires. These are the some of the initiative in Uttarakhand especially. So they engage this forest staffs for the prevention. They sometimes they create forest line. This is this beating of this fire in the forest for the further spread. If there is crown burning, they use sometimes this hose pipes to sprinkle these fires with water to dose it. They do this beating with these twigs and leaves. And they use also this for fire department for the prevention and control. So these are the some of the photographs from the initiatives. It is not only day exercise, sometimes day night both. They do this. You can see the loss of forest fire because of the forest fire, loss of this forest flora, and this all this, even the crown level burning. So it will take now time to regain to its original state. So there is immense loss, and all the floras and other biodiversity in this region, you can clearly visualize how it has been destroyed and lost. So you can see SDRF people engaged in this Uttarakhand when there was intense fire. Sometimes they also take the help of Air Force helicopter, because the intensity sometimes it is into the inaccessible areas there. This is the only way they do sprinkling of water using Indian Air Force helicopters. Some community based initiative already JFMs is established, village forest protection committees are there, they take the help of, and they try to sensitize these groups also. These are the various ways in Uttarakhand where they are doing this awareness, some training, specialized training programs also for engaging community, always as well as for training the forest staff itself. It is being done time to time. National Institute of Disaster Management (NIDM) in Delhi, under the Home Ministry, they very often organize this such kind of training program, especially at Forest Research Institute (FRI). We initiate 1 week training program where we invite the various resource person and the staffs from forest department for making them aware about the various aspects of this forest fire prevention and control. All this methodology developed by the FRI itself, how they can really implement into the field, what initiative they can do for the prevention and control of the forest fire. All this part of training, and it's a regular training by FRI and NIDM. Community sensitization is also done, and this in Uttarakhand, especially pine needle, they are available in large amount, and they are the readily available source of fire as a fuel. So timely removal of this fuel resources from the forest floor, so that there is less chances of this fire. That such initiatives have been taken by the government of Uttarakhand. Nowadays they have focused this for this management of this needle. They have now initiated gasification system where they will take this fuel for the generation of electricity. That is also under the initialization step. So in due course we can link these fuel resources directly to the establishments where gasification process is going, so that communities are encouraged to collect and bring those resources to this gasification unit, so that automatically there is less pine needle left into the forest floor, and so the less chances of spread of this forest fire in these pine dominant belts of Uttarakhand. So these are the few photographs through which you can be ensured that about the intensity and the quantity of the large amount of needle that is being generated by these pine dominated communities in the Uttarakhand region. So these are the few photographs where communities are collecting litters, and litters, they act as a readily available source of fuel for the spread of forest fire. So this initiative is also taken care of by this government of Uttarakhand. Especially if in northeast states, there is some incentives given to the various level where there is less intensity, less number of forest fire occurrences. The government tries to incentives, give some incentives to the community, so that they are encouraged to suppress this forest fire in their locality. So this has shown some good successful result in this northeast region. Now with this, we will try to finish further things very fastly, so that we have little bit time for the conversation, for two-way communication, for exchange of question and answer. That will be more fruitful for you. So now this forest cover mapping and change detection. For forest cover mapping, for forestry people, the moment you say forest cover, they will simply understand the different forest cover density of the forest. So this, if you are doing this cover monitoring, maybe you are interested in just one distinguishing the land surface into two groups, that's forest area and non-forested area. And within this forested area, maybe you are interested in classifying your forested landscape based upon the canopy density, because your sensor, they are looking from the top, they are able to see the canopy. And when there is very dense forest, the canopy will be very close. And when there is open forest, canopy opening will be there. You will find some spaces in between the pixels where there is no forest. And based upon this density of these pixels representing forest, you are defining your area into different forest density classes. And then based upon the kind of species dominant in your study area, maybe sometime we are defining into different forest types. That classification is also there. Sometimes you are interested in more other parameters of this forest, like what is the standing volume, standing biomass. Somebody has come, 1 minute. My class is going, class. So now with this, if you want to visualize changes with respect to any of this component, maybe relating your forest cover density or changes in one forest type into another forest type in present scenario or in the future scenario, or maybe the changes is one or more biophysical parameters of the forest in either in present scenario or in during the past, because you have the archive images of satellite retrieved from this satellite sensor. So you can do all such analysis for the past period also. And using some vegetation model, which we will be seeing as a third component of our presentation, my presentation, you can do such kind of change prediction for our future scenarios also using some vegetation models. So all this change detection can be linked to all these things primarily. And we will see some of the terms, some of the initiatives by different, like it is forest cover mapping, forest cover density. After every alternate year, Forest Survey of India, they come with a report called as the India State of Forest Report, ISFR. They publish for this kind of statistics for entire India at district level. They provide this change in one density classes into another. How much is the forest area into very dense forest category, into moderate density forest category, open and scrub. Usually based upon their canopy closing and opening, they classify these different density classes. So you can have this readily available map from Forest Survey of India and there you will find this legend in terms of this 4 classes of this forest density, and 3, this other 2 are the non-forest class. One is non-forest, another water pixels. In forest density class, you will have very dense forest, moderate dense forest, open forest, scrub. So in very dense forest, VDF, in abbreviation, you will find in report written as VDF, MDF, where the canopy density is more than 70%. They classify it as very dense forest. Where the canopy density is in between 40 to 70, they classify it as moderately dense forest. When the canopy density is in between 10 to 40%, they classify open forest. Where the canopy is less than 10, they classify it as a scrub. So they say it as the forest cover mapping. It is basically the forest cover density mapping, where you receive these 4 different canopy density classes and non-forest and water classes also. So these maps are available for entire India. And after every 2 years, this is the regular exercise done by Forest Survey of India. They come with updated map and they do all kind of change detection interpretation you can do using their map, or you can develop similar map if you have the facility of ground truthing, where you do in the first class by Dr. PK Joshi. He saw you what is ground truthing. Ground truthing is must. You go into the ground and confirm whether if I am classifying this forest, actually it is forest in the ground or not. So if you have such kind of facility, you such a access, such a human resources and time, you can also develop using similar this images, all those archived images which is freely available. They are using list 3, which is freely available. You can use other sensors also like Sentinel and MODIS. You can develop such kind of images. And you can do all this change analysis, what kind of changes in your study area from one density class to another density class, or from one forest type to into another forest type has occurred and how much had occurred. This is one simple exercise, very most of the people in some of the project is required and people are doing very frequently. So it is at the not very fine resolution. You will, although the images are freely available, the pixel size is sometime 30, sometime Sentinel is giving also at 10-meter resolution. It is freely available at 24 or 25-meter resolution. This list 3. So all this within this 30 or 25-meter pixel size, whatever there is, one single value you are getting. So for the mapping of some invasive species, or for those species we are not very occurring in a very high continuous density classes, maybe in 30-meter only a small portion of a corner is occupied, and there it is very difficult to detect those signature and it is difficult to classify those at this resolution. So there you can do this sub pixel classification to get information at that level also using this moderate, even this moderate resolution. This one exercise was done for Geospatial. It is one of the invasive species in Uttarakhand region and this western parts of this UP also. So at using this 30-meter resolution, this modest based not modest Landsat images, even at that resolution you can detect this. This is the fractional cover of this Heptis has been done in this image, where this red pixels denotes that there is high fractional coverage within the pixels. So easily we are able to detect the areas where there is already the Heptis has been embedded. So such kind of exercise is also possible using this remote sensing. Once you are into this field, you will be able to do all this. See, it is very simple exercise, although it may be those who are not using it. Some days back, I was also not using this. I used to amaze how this wonderful science is there. Why I am not able to do this. So once you start doing, it becomes all easy. But these are some of the possibilities, some of the works that can be done that is possible using remote sensing that I wanted to highlight, that I wanted to show. This forest type mapping is also possible using this space-based signature. You can do this categorization of your area into different forest types. Like for forest canopy density, if you do manually ocular observation, go into the field. If you want to do manually, you will be doing such kind of thing. If you look up above the sky, you see such kind of opening, or using some prism. In prism, you are counting this number of images coming from the forest and the number of open spaces. Accordingly, you are trying to classify your canopy density. Then for the same area, you are having these digital images taken by some sensors, maybe aerial or maybe your satellite based sensor. There again, this is represented in your image in different pixels, and based upon the count density of the pixels representing forest, you can classify your region into different canopy density classes. That's the thing we are doing. Like if you use this pan images, panchromatic images, they are also easily you will be able to distinguish different density classes, where there is low density, where there is high density, you can be able to see. And doing on screen manual interpretation also, sometimes people are demarking manually on the screen, doing digitization, where there is high density, where there is low density. All this such kind of work is possible. So where there is high density, you can see the signature is different. Where there is low density, you will find mixing of these bright and dark pixels. So accordingly, you can classify these areas. For forest type mapping, vegetation mapping, you are using multiple sources. Like sometime you require your climatic parameters also to classify your study area into different biogeographic zones, because one biogeographic zone will have one kind of prevalent forest type system. And using this remote sensing satellite images, you are classifying your study area into different forest type. This exercise people do. Especially IRS has developed this vegetation map for entire India. You can have a free access to, you can download for a small area, not for entire India. You at a one single download they will allow you, but for a smaller area you can download freely to their web-based resources. So according to IIRS, this some of the, for some of your forest dominant landscape of India, not all the time is suitable for using your satellite images. Maybe in some of your area there is leaf fall. So in your remote sensing images, when there is leaf fall, maybe in those images your forests are not detected well. So accordingly, for different part of the nation, different suitable seasons have been suggested by IRS for using the satellite based imagery. For your eastern Himalayan region, the preferred season is December, January and April, May. So all those, the archive images you will be getting for entire continuous period of entire year, but not those all images, especially the rainy season, you will have disturbances because of cloud and rain. So not much clear information you will be getting. So accordingly, you can select the region for the use of the images for this classification. So in change detection for Tripura, using some Google Earth images, also you can very easily, Google Earth now it is very user friendly, anyone can use it. They are also based upon the availability of the images there and their time lag, they have after certain interval of time, not continuous images you will be getting, but there they have these images you can use for change detection. Now at the last, I will very fastly try to cover this one of the interesting topic where especially we are focusing. We working at IT and GIS department. Our domain is basically in this vegetation modeling. So vegetation models are usually the computer-based program. You people are from agriculture field. So in agriculture also people are using these models, crop models. We show there the crop models like InfoCrop is very much popular, developed by Indian Agriculture Research Institute, IARI, where you have the privilege to feed all those climatic related parameters or management related parameters, and accordingly you can visualize what kind of yield is expected in a particular given scenario. Likewise for forest, your agriculture crops are very short, they have short time period, unlike our forest which is a long time period crop. It is also we say it also as a crop only. So but their long time observation is required. So maybe even if I want to have a continuous observation for one particular species, my entire research career time will not be enough to compile all those information for a given forest crop. But for vegetation crop, it is possible. Maybe in 5 years, 5 times I will be having complete cycle observation and all those values, and I can easily make some mathematical equations to represent all those functional behavior, the relationship with other parameter that is influencing its growth and yield. So all those things is in a similar way done for the forest ecosystem, where the productivity, the gain in biomass per unit area per unit time, we are trying to visualize with while relating it with the various climatic parameter and the surrounding environment, other management aspects, forest fires, sometimes insect attacks, the negative one and the positive one, both one. So that those are the vegetation models we use in this forestry. So very fastly, there are two models, and especially these vegetation models are used for future projections. Like suppose in future, this will be our kind of climate, temperature, precipitation and all. Then what kind of vegetation is visualized in a given time period, maybe what kind of forest type will be prevalent. Earlier in past years, this kind of forest type was prevalent, but if the circumstances, climate changes, how the in future the different possibility of occurrence of or the replacement of one forest type by another forest type is possible. Those visualization is possible using these vegetation models. And where in my study landscape, where the productivity will fall down, where the productivity is expected to remain same, or where the productivity is expected to even enhance, all those visualization is possible using vegetation model. And Broadly, we should not be confused with the climate model. Climate models are used for prediction of your future climate. And under those future predicted climate, that acts here in the vegetation model, those predicted climatic files act as an input. Under those projected climate, how our forest will behave. So those things we are doing in vegetation model. So some definition of climate change, hopefully you must be aware what is climate change. It is any standard deviation in average value of any climatic parameter for a observation roughly taken for the 30 years period time. If there is significant change, we say it is there is climate change. So IPCC and UNFCCC broadly they classify in different way. UNFCCC focuses much on the changes that is not natural, that is human induced. They define this climate change in this way, that is in addition to the natural changes, because climate, even if there is no human activity, there will be climate change that occurs naturally because of all multiple phenomenon, distance of earth changing from the sun. So this way people are there is change, but we are focusing changes related to this mostly human induced. So climate models gives you the future climate prediction, but vegetation models gives you under those predicted climatic predictions, how and how why in which way our forest will behave. Those are vegetation models. So these are some slides related to climate scenarios, because what will be future climate, generally it is very difficult to predict the future climate. It depends upon the level of emissions, level of green technology it is evolving. So there can be different level of industrialization development, but at the same time there can be various kind of green technology evolution also. So we hypothetically generate a scenario, and supposing that system warming is maybe in one scenario there is growth in the emission, and because of emission there is warming of the atmosphere at a rate of this 2.6 watt per meter square. We call it as the RCP 2.6 scenario. Under that we see that peak is before 2100 and then tries to decline after year 2100, there will be decline. So this is the more better scenarios, but the worst scenario is RCP 8.5, where this peak will continue to increase after even this end of this century. And this is the worst scenario most. And in all these assumptions, under all this scenario, we try to visualize if the scenario is like 2.6, how our forest will behave. If it is like this middle scenario 4.5 or 6, how our forest will behave. If it is worst scenario, how our forest will behave. You try to predict using this vegetation model. If you see the climate related models for prediction of future climate, there are various models used by various countries. This is the name of the country. Here you will not find our name of our India, because these countries, these institutes, they are specialized institutes where large amount of human resources, large amount of dedicated trained human resources, heavy computational facilities, those are all working day and night continuously for one single theme that is related to the prediction of your future climate. But in India, we are mostly using the ready-made product developed by these research communities, and mostly Indian Institute of Tropical Meteorology, Pune, IITM, Pune, they are doing all this handling, processing. So we don't have dedicated models. We use existing models. Likewise, it is for the vegetation model also. We still don't have our own vegetation model. Why forest is important? If you see the contribution of emissions that is leading to the climate change, the warming of your atmosphere through various sectors like crop residue burning, forest and all. Here you see this forest, land use change and forestry, this column, this bottom one, you see that there is large variation. In this coming decade, this has dropped down. This contribution from land use change and forestry has dropped down, but all other contribution, you will find that is more and less same. So because of the intervention we are taking into the forestry, managing the forestry so that there is less burning, less emissions of carbon dioxide, less degradation. So with that, we are able to manage, and this coming decade, the contribution of emission or the contribution of global warming, contribution of climate change from forestry sector, that has dropped. So forestry plays a big role, we can see, in this climate change and this emission scenario. So this is one of the major focus area if you are talking in terms of managing your climate. So vegetation model, basically they are the mathematical equation that is written through computer based programs where you can fine tune one parameter and related linked parameters of this forest ecosystem like its productivity or the forest type. You can visualize how it is changing as you do in your vegetation crop models. So there are various approaches. Initially, people just started to do all these things using some simple statistical equations like regression equation. These are the parameters of climate, and this is the yield. How this climatic parameter and yield is related. Simple regression equation you can develop. Or maybe gradually they started linking this geochemical and processes at a smaller level, sometimes using some statistical equation. Then gradually we started developing all those then this small is lab for all this prediction at a small lab forest patch, a small area, then at a landscape level. And now this latest one, dynamic global vegetation model, that uses processes of the plants and its linkages with the surrounding environment and management interventions onto the kind of type or the productivity it is impacting. We use this dynamic global vegetation model. This is the most recent one and the most accurate one, most complicated one also. It is not easy to compile all those linked file. If you are not a part of developer team, sometimes it becomes very much difficult. So with the help of the people who are already working into the domain, you can either use the existing models or you can start to initiate some initial framework for developing such models. And we here at FRI, we are especially working in that direction. We are also using the existing models and we are trying to develop a small modules as far as for a given species. The number of observation, the kind of observation is improving. We are trying to convert it into small modules so that all modules at last, if we add, we can develop our independent dynamic vegetation models. So these are the some models existing which people are using in your publication. If you see the journals publication, maybe few terms you must have heard among what is shown here in this slide. So mostly in FRI, we have tested all these Maxent, GARD, DNDC, Landis, IBIS. Recently LPJ and Jules also we have tested. So very fastly I will try to escape this slide so that we have the more times to for discussion. So some Indian perspective related to research requirement into the forest vegetation model development that has been highlighted. This is infocrop model developed by IARI, which you might have seen or you must have also used for various crops. For nowadays, a number of crops is gradually increasing. Initially, it was developed for rice and just few dominant crops, but other dominant crops now also have been added into the modules of infocrop. So if you try to visualize a model, various interactions taking place into the environment of a crop, that is being written as a computer program, and all those linked chains are also present there. Their switches are also used. So in if you start developing, maybe you can start from just one parameter, evaporation, infiltration. Somebody is doing some work on nitrogen stress, somebody on some another parameter, and some connectivity you see it is showing. Maybe everything is fine. And if all the groups come sit together and they try to join all this module, they come with such kind of models. That is infocrop model developed by IARI. So similar kind of work initiative we are doing here at FRI. Some DSET model developed by another country earlier. Nowadays also few people working in agriculture field, they are using this DSET model predictions. This Maxent is also used in this, that is using presence absence locations for predicting the suitable needs of a particular species. They are using this. They are also used in prediction of the habitat shift for under given climate change scenarios. So some of the steps how to use this model that has been highlighted in this coming slides. I will escape these slides. I will come very fastly. This is the site of IBIS, one of the vegetation model. You can access this slide. You can download this model. You can run this. All the steps are given, and you can have results. You can run it this code. These are the steps, and such kind of maps you will be getting related to the kind of dominant of one forest in a given time period under given scenarios you will be getting. So maybe for working in this field, you will require either one kind of tool or multiple tools. So this is the result shown by Indian Institute of Science. They used IBIS model, and this is the result highlighted. Again, this is the same result. This is one study done by us for Indian Himalayan forest using some, we initially did some trend analysis of productivity retrieved through MODIS. MODIS gives you this NPP also, net primary productivity. So first over the given time period, we analyzed this productivity. We could see that after processing of MODIS data, we could see unexpectedly this high level of NPP in these years. So we simply excluded this and we used only this year data, and we can see that over the year more or less the productivity is increasing. So people say that after climate change there is a lot of hue and cry, but we actually see, if we see the observation, productivity over the time period more or less it is increasing, but it is for this present prevailing scenario. If the scenario goes on increasing, if the climate change becomes more worst kind of situation, maybe we will find in due course a decline in this kind of productivity trend. So various studies which have linked this productivity with the climatic variables of parameter, they have also highlighted, because in due course CO2 concentration is increasing, and it talks this fertilization effect of the CO2 increase in concentration, it is improving the productivity of forested areas. So some of the relationship established between the productivity and temperature we have highlighted. With precipitation you can see, and it is significant one shown with a star, and this R is 0.83 correlation. If you try to establish, it is highly correlated with the wet days frequency. More number of wet days, more the frequency, more is the productivity in a forest region. So all this you can see the existing models, vegetation models. IBIS was tested by this Indian Institute of Science, which in previous slide we saw the result. There are the various models. So with the very little progress for India, we don't have yet this such kind of models that is widely accepted by all the research groups of various countries. But the models developed by other countries, they are wide in use. Some of the results using this Jules model, one of the vegetation model for this Himalayan region forest, including this western as well as eastern Himalayan part. The first thing is we did this classification of forest into different forest grids. Maybe in one grid there is forest, but the forest is less than 5%. We selected and we considered those grids only where we defined those grids as a forest. Like if here you can see few dots of forest, but if I make a grid over here of 50 kilometer size, 0.5 degree roughly, size equivalent to the size of the climatic predictions at which these climatic projections files are available, we could see that the regions where the forest is less than 5%, we have excluded it in the study, and we could identify that 213 forest such grids are existing, and accordingly we have defined how many grids and which grids are vulnerable under which scenarios using these vegetation models. So some of the theories which we used for predicting this vulnerability that has been highlighted. I will escape this. So these are the results. Because the time is almost ending, I want to give some time for discussion, so I am escaping. These are the results predicted by this vegetation model. I will come directly to the results. We discussed that we have to consider various change scenarios, climate change scenarios. Under 2.6, when there a warming is expected at the level of 2.6 watt per meter square, by the end of 2030, for different forest types prevailing in our country, this vulnerability classes, how much area is going into low vulnerability, into moderate, into high, and very high. So mostly 86.8, mostly the forest grids are in the low vulnerability classes, and very less are in falling into high and very high vulnerability classes. Especially where there is high vulnerability percentage, we have highlighted with this red. So more or less we can see that for by the end of 2050 or even by the end of 2030, there is very less forested grids that falls under this very high and this moderate and high also. Mostly we are seeing that the forests are into the low vulnerability classes, means our forests have got the capability to adjust to the changing climate and they will face the effects of changing climate, but under this 2.6 warming scenario. But if the warming is at the level of 4.5 watt per meter square, you can see the percentage under moderate and high vulnerability classes has increased for all the 3 years. So likewise, we can highlight for other scenarios also and using other models also. So these are the some of the conclusion which we have derived using this study. I am escaping this conclusion. I can simply email the slide. You can read it itself. You understandable. You can understand it while reading it. So with this, before I end, I acknowledge one of the resource person at FRI, Dr. Amit Verma, who works with me. And then Mr. Ram Kumar, he also work in close association with me. He is from Hexagon Geospatial, which sells this ADA software. And I am humbly thankful to Director FRI and all the academic staffs, all the members of Central Agriculture University Impal, and all the resource person academicians of this horticulture center of your Pasigad. And with this, I end this. Now I will open this floor for the question answer session. So thank you very much.
Okay.
If you have any query, this is my email
Thank
ID.
you.
You can throw the email. Okay.
Thank you very much to Dr. Manoj Kumar. Actually, you have done a lot of effort in presenting the preparing the slides. I was also going through with interest. I expect the participants have got a lot of information and concept from your presentation. It is a marvelous presentation, I can say. Anyhow, there was some disturbance in between, but the presentation and today's lecture was an excellent one. So Dr. Manoj was asked to present a topic on the forest fire monitoring, mapping, change detection by geospatial technology. So he has covered almost all the aspects as I have mentioned earlier. One thing is newly we are also got a lot of information. We have got that some of the sites are there like FSI and NASA, where you will also get some free information as far as the forest fire analysis is concerned. And in the last, he has also mentioned about a new topic regarding the modeling. So he has also mentioned about the vegetation modeling. Now efforts are being taken to go for the forest modeling also. And he has also given some of the case studies regarding the forest modeling also, and other models available at the global level. Anyhow, I expect the students, faculties and scientists have got lot of informations from his lecture. Really, Dr. Sahab, I am very much thankful to you. So now I can tell my participants that if they have some queries, they can hurriedly they can ask some of the queries. If not possible, I can share Dr. Manoj's email, so through which they can contact him, because we are having another session at the afternoon after lunch. So we'll end up here, but we just wait for 5 minutes so to get some feedback from our participants, please.
Is there any question in the
Yes.
chat box?
One.
Any question you just asking?
Kindly unmute the
Yeah,
participants now.
one question.
You can
One
unmute the
question, Dr.
participants.
Manoj. Oh,
Yeah, I'll do.
you do.
And chat box.
Now I can see Dr. Manoj from the chat box that some Ram Singh has some query like, sir, what is the linkage between the climate and vegetation model?
Before that, you can stop screen sharing. No?
Let me
You
open the
please
chat box.
stop your screen sharing. Dr. Sahab, you can
Okay.
stop your screen sharing.
So you can read out the question. I am searching where it is available. Chats. It is available.
It is there. Some of the thanks
What is
also
the
our
linkage
participants
between
have
climate and vegetation models? Like
Okay.
vegetation models itself, it is based upon your observation only. What kind of observation through various research groups you are getting, and those linkages you yourself you are feeding into the models. So based upon the actual field observation, which different research groups they are observing, maybe using some flux based towers or some in situ observation or some remote sensing based observation, they develop these linkages and they feed it into the models. So these models itself, they have the equations where these linkages are there. So once the linkages are there, if you change the parameters of any climate, if it is already embedded into the equation, you can visualize the how other parameter of vegetation is changing. So this way these models are working. So this way it is linked.
Okay, thank you, Dr. Manoj. So if there is no question, we can end up the session here. And dear participants, we will meet at 3 o'clock. We have another important speaker from IIRS Dehradun. So please, we'll end here. Thank you, Dr. Manoj, and all the participants who have participated in this session. Please. Thank you all.
Thank you, sir. Thank you once again. I have shared my email ID. I will also email this slide to you so that you can share.
Okay, thank you, Dr. Okay, we'll be in touch. Okay.
Okay, thank you.